Here's our attempt. I'm going to look at myself again in the beautiful mirror here and see, am I presenting what I think I'm presenting? I am. All right. So outcome, I can calculate the value of the derivative for remaining 4 derivatives. If you watched the video yesterday, you should have seen something where they showed a shortcut where if you can remember secant x, tangent x, and cosecant x, cotangent x, and if you can remember to put a negative here, then that's going to help you remember the other 4 derivatives. So in this particular case, we have h of x equals secant x, and I need to find h prime. Well, h prime is, I say, oh, I want to find the derivative of secant x. It's what's remaining. This is just a little mnemonic. It's not anything special. It's just there to help you remember things. So you don't need to look at a file. But then after you remember your 4 derivatives, you got to plug in a number, and then it gets even more tricky because you have your glorious unit circle, and you have to go, okay, where is 0? It's right here. And what are the coordinates? 1, 0. And remember, that's the cosine value, and that's the sine value. And so you're thinking about that. You're going, oh, secant, that's 1 over cosine. Oh, tangent, that's sine over cosine. So sine over cosine, that's what that says. So let's make that a little clearer so we can see that. And when we do that, we realize that that's the same thing as saying 1 over 1 times 0 over 1. So we get 0. So there we go. With that being said, that was a review of last night's video and last night's homework of one of the beautiful things we need to be able to do. There was a problem last night, so if you just thought it was a video to watch, there's a problem you need to turn in. So make sure you turn it in. Now, the big notes for the day, they're going to take about 20 minutes for us to do, and then the remainder of time is you being able to work on your Delta Math. So you'll get time to do that, and then obviously you have to finish it up tomorrow. So chain rule, we've done power rule, which is an exponent. We've done product rule, which is multiplication. We've done quotient rule, which is division. Now we're doing the chain, and probably the most important because it's the one that comes up so often. This is for composite functions, those functions where one function is inside the other. So the big thing to recognize is the derivative of a composite function, f of g of x. So g of x is inside of g of x. You do the derivative of the outside function. You keep the inside function the same, and then you multiply by the derivative of the inside function. Again, FOG. When you see this thing and it's not darkened in, that is your heads up that this is a combination function. I'm just going to make sure you understand that these two things mean the same thing, and it looks the exact same way, okay? So h prime x is f prime x, keep the g of x the same, times the g of x. So what is this kind of thing? A lot of times you're going to see this talk about f and u. Oh my gosh, you got a little PG-13 up in here, all right? F being the outside function. So we take the derivative of the outside function, we leave the inside function the same, and then we multiply by the derivative of that inside function. So that is yet another way you're going to see chain rule. So 3 different ways, 3 different type things. The chain rule is kind of known as the outside inside rule. There's an outside function, there's an inside function, and we want to know the same. So I heard the chat go off. What does the chat say? I like that joke. Thank you, Isaiah. I try. So there we go. We have the following. Find y prime if y equals sine of x squared. Notice how I'm saying it out loud. You need to practice saying it out loud this way. Sine, yes. I can. Give me the thumbs up when you are ready. You're very welcome. All right, so we have a function, y equals sine of x squared, okay? So let's keep in mind this, the sine, that's my outside function. And x squared, that's my inside function. And it's so easy for you most of the time to know there's an inside function because there will be parentheses there, okay? So what's the derivative? We take the derivative of the outside function, cosine. We leave that inside function the same, and then we multiply by the derivative of the inside function. And keep in mind, it's most likely going to have the 2x out in front. So when you look on an answer key or something, it will most likely look like so. So use a sine of x squared, kind of like f of g of x. There's a function on the outside. There's a function on the inside. So then we're going to do the derivative of outside, keep the inside the same, and then multiply by the derivative of the inside. Oops, I must have hit a plus sign. Let's try another one. Okay, we have e to the 7x. Do you know when you put this in your calculator, a lot of times it wants you to do this, or it wants you to do this, like a box in there and stuff. So there's an outside function, that's my e, and there's an inside function. We'll actually talk more about this on Friday when we deal more with exponentials and logs again. But what's the derivative of e to the something? It's just e to the something. So we just keep the e and the x the same, and then multiply by the derivative of the inside function, or the thing that went to the inside. So if I was entering this in my calculator, it would probably look something like that. So that way we have our outside function, we have our inside function. Again, try to think about how when you enter this in your calculator, it will look. Do you need to put it inside a box? Do you need to put it inside parentheses? That'll help you pick what your inside function is and what your outside function is. So we just talked about secant. This was on yesterday's homework, and it was also on the drill. So secant is our outside function. 5x is our inside function. Okay, so we get this beautiful thing. So I'm gonna go off to the side because I sometimes have trouble remembering my trig derivatives. So I make my little chart there, and I remember that, oh, cover up the one you want, and then whatever's left in its row is the derivative. So now I have that f prime x equals, and let's do the derivative of the outside, secant tangent, keep the inside function the same, and then multiply by the derivative of the inside function. There you go, my friends. I'm going to put this down here. All right. What do we have here? We have y equals the quantity x squared plus 3x plus 4th raised to the 4th power. Now, you might be going, this doesn't look like the other ones, but we have ourselves an inside function because this is inside parentheses. So there's my inside function. So who's my outside function? Raising something to the 30th power is my outside function. So how do I take the derivative of something that's being raised to the 30th power? That's the power rule. So the derivative of f is multiply the front by 30 and subtract 1 from the exponent. Ah, how about that? Keep the inside the same. And then multiply by the derivative of the inside. Now, this is very naughty what I've written over here because I am telling you to multiply by 2x, get an answer, and then add 3 to it. And that's not what I want to be saying. I want to be saying multiplying by the quantity, 2x plus 3. So I'm going to write a little reminder to myself, don't forget the parentheses when there's more than one term going on over there. Okay, so don't forget the parentheses. So again, we had an outside function take the derivative, keep the inside the same, multiply by the derivative of the inside function. There's just a bunch of examples here, guys. So we're going to do like about 5 more examples and then go from there and try to practice these bad boys. All right, so here's another one. We got a radical, ladies and gentlemen. What are you supposed to do when you have a radical? Remember, when we're taking a derivative. Oh, do I need to go back? Oh, nope, I don't know. All right. Remember, when you have a radical, you need to change it to raise over root. So the inside's being raised to the 1, and it's being rooted by the 5th. So that's what you had to do to set it up, ladies and gentlemen. That's the setup. We haven't taken the derivative. All right. I got a whole bunch of stuff going on here, but I do see I have an inside function and I have an outside function. Ooh. So let's do it. Derivative of the outside requires multiplying. Subtract 1 from the exponent. Keep the inside the same. Multiply by the derivative of the inside using the power rule. Is there more than one term when I have the derivative of the inside? There is. So don't forget the parentheses. I'm going to write it again. Don't forget the parentheses. All right. So again, now you notice at the start, the problem was already the way I needed it to be. Then on this one, I saw a radical, so I had to rewrite it. Okay, so we might have some more examples. Oh, I have a 2. I have a division. I have a radical. Oh, I can go back. Give me the heads up when you are finished. All right. So we have this guy. We have 2 divided by the square root of 4x minus 7. Well, guys, remember, we don't usually want square roots, and we would prefer not to have x's in the denominator. So let's think about this. This was on our problem set this past week. I had an x in the denominator that also happened to be a square root. So let's go ahead and rewrite this. I'm going to rewrite this in black instead of red. So let's go ahead and rewrite this. We're going to have 2. How do we get make this an exponent? Square rooting something is the same as raising it to the 1/2. And then I want to move it from the denominator to the numerator. Change the sign of the exponent. So again, a square root is to the 1/2 power, and getting it to go from the denominator to the numerator, you just have to change the sign of its exponent. Okay, who's our outside function and who's our inside function? Well, these guys right here are my outside functions. This guy right here is my inside function. So how do I do a power rule when I have a power and I have a constant out in front? Same as I always did. I take the exponent and multiply it to the number out front. So -1/2 times 2, which is the same thing as -1, which I'll just go ahead and write that there. Subtract 1 from the exponent. Leave the inside the same. Times the derivative of the inside. What's the derivative of 4x to the first power? 4x to the 0. We don't need to write the x to the 0. What's the derivative of 7? 0. We don't have to write 0 unless that's the only term. So I'm going to go ahead and erase that so I don't have to put parentheses there. Again, the derivative of 4x was 4. The derivative of 7 was 0. And then if I wanted to simplify this, I get y prime equals -4. I just combine those two numbers. And then 4x minus 7 to the -3/2. Okay, so we started out with just having an inside and an outside. This one required you to rewrite and then have an inside and an outside. So the last two examples are kind of like that as well. So let's look at what we might have for these last examples that we have coming up here. Oh my, sine 5x squared. What is this 5 telling me to do? If you forgot, it is telling you to raise the entire thing to the 5th power. And I'm actually going to use 3 colors here so you can see it better. I'm going to use blue for the 5th power. I'm going to use red for the sine. And I'm going to use green for the x squared. So that you can see, oh, who's the most outside function? All right, so we have f. We have a U. Oh gosh, and we even have a W here because we have so many things, folks. So what do we do for the chain rule? Always start with the outside function. So let's do the outside function first. 5 raised to the 4th. That's the start of it, my friends. Remember the chain rule. Do the outside. What do we do with the inside? We keep it the same. So we're going to keep this the same. Now we got to take the derivative of the inside function. Oh, but wait, people. Look at the inside. We have, oops, I should have done. Look at this. The inside has its own inside. So we got to do that process again. Take the derivative of the outside. Leave the inside function the same. And then finally multiply it by the inside. So ladies and gentlemen, we had 3 functions here. We had to the 5th power, we had sine, we have x squared. You start with the most outside, keep the next inside the same. So start with the 5, keep the inside the same. Start with the sine, keep the inside the same, and then end with the derivative of the final inside. So 5 to the 4th, then you do the sine as cosine, then you do the derivative of x squared as 2x. And it would finally, in a multiple choice problem, would look formatted. You have a 5, you have a 2x, that would become 10x. This 4 means we are raising the entire function, the 4th root, excuse me, the 4th sign right there. That means that, and then we have cosine x squared. So this is the way it would probably look formatted in a multiple choice scenario. Remember, free response problems, you can leave it as simplified as that multicolor one. Okay, we're going to do another problem exactly like this. So you have 2 examples within your notes. Again, I highly suggest if you have flare pens or multiple colors or something of that nature, you use it. I always post my notes in the multicolor. So if you're using my notes that get posted to the classroom, you will have it again. So let's rewrite this guy. We have a 7th power. That's my main outside function. We have cosine, and we have a 3x that's on the inside. So I got to go blue, red, green, if you can see the colors on my screen. Blue, red, green. Take the derivative of the blue. Take the derivative of the blue. Keep the green and red the same. Okay? Now we're going to ignore blue. We've taken care of blue. Blue is done. Outside function, the 7th power, we've taken care of that. Let's multiply by the derivative of the red. The derivative of the red is negative sign, but keep that 3x the same. And now we can end it on taking the derivative of the green. So derivative of blue, keep red and green the same. Derivative of red, keep green the same. Derivative of green. So one at a time, in the order that they appear on from most outside to inside. So derivative of the blue, keep red and green. Derivative of the red, keep green. Derivative of the green. We're done. And what would that look like as a simplified answer? You have a 7, you have a negative 1, you have a 3. So that makes it a negative 21 out in front. And then remember, raising something to the 6th for a trig function is like putting that there. And the reason it gets written there is so you know the entire function is being raised to the 6th power and not just the 3x. So cosine with the 6 here means the cosine 3x is being raised to the 6th power. And then we have a sine of 3x. And there is your answer. So those are two of the most common that you will see for these types of problems. So I'm just going to go back to the top really quickly. Sometimes it's as easy as here's my outside, here's my inside. There you have a parentheses, it's pretty clear. Here's my outside, here's my inside. There's my inside, there's my outside. Sometimes it's clear as day, you have a parentheses. Sometimes you need to rewrite the problem so that it has a parentheses. And sometimes you need to rewrite the problem where it has two sets of parentheses. Start on the most outside and work your way in. That's probably the most complicated it ever gets. This kind of problem right here is the most complicated it will ever get. We have one more example for the notes, and that is tables. Okay, so remember when we did tables with product and quotient rule, you must know your notation. So h of x is f of g of x. Get used to saying it out loud correctly. F of g of x. And it's asking me to find h prime and then plug in 1. So we need to know, all right, h prime of x, you take the derivative of the outside function, which is f. You leave the inside function the same. And then you multiply by the derivative of the inside function. Now this is asking me to find h prime of 1. So let's just go ahead and everywhere it says the number 1, that's what I'm going to put 1 in for x. Everything else I'm going to keep exactly the same. So I'm going to go in here and write all my things in here. Okay. So all I did was I went in and I replaced all my x's with 1s. And now I have to use the table. So let's use the table. Let's go ahead and use the table and see what we get, ladies and gentlemen. First of all, g of 1. Here's g. Here's 1. Here's 2. So we go f prime. Actually, you know what? I'm going to do that in blue. F prime. And g of 1 was 2. Okay. Times g prime of 1. G prime, 1. There's the 9 right there. So times 9. Okay. Uh-oh, I still have f prime of 2 to do. Now, you've had problems like this before where you had a value. You had to get the value, and then you had to plug it into the other function. So g of 1 was 2. We take the 2, and we figure out what f prime of 2 is. So let's find out what f prime of 2. Here's f prime. Here's 2. Let's plug in that 5. So f prime of 2 is 5. And then we have this times 9. So our final answer is 45. So that is the way we have our tables being done in this particular problem. Pretty cool. Okay, so again, we have problems that start off pretty straightforward. They say something like this, where it's like an inside and an outside. Then we have problems where it's like, oh, I need to rewrite something. I got a radical. I need to get the parentheses. And then sometimes you have, oh, there's 2 sets of parentheses. So I got to take care of the first one, leave the others the same, and then just go in this like color order on those. And then you have tables. So we have those kind of concepts for chain rule. If you can master today, you can master chain rule. I like to keep this little chart handy because not only does it have all the rules I've been learning with respect to trig functions, exponentials, logs, and power rule, but when there's something else going on, we got to do that du as well. So the derivative of sine is cosine, but if there's something else in there, we got to take the derivative of the something else in there. Or the derivative of tangent is secant squared, but if there's something else in there, we also got to do the derivative of that something in there. So that, I like this little chart to keep handy for chain rule type of things. Now, ladies and gentlemen, you have a slew of problems that you can start with 17 minutes to go. Am I doing my math right? Yes, 17 minutes to go in class. And also what you have here